All right, this is Algebra 2, Lesson 118, Logarithmic Equations, on the bottom of page 479. There are some problems in your book that look like this. And you're going to do this in science today.
Today?
I do believe, yes. All right, so look at problem 10 from lesson 117 on page 478. It's just on the preceding page. Do you see that? It says the pH of a solution is given by this equation, where H positive is the concentration of hydrogen ions in moles per liter. Find the H positive. That's what we're looking for. Find the H positive when the pH, we're just going to do the first one, is 5.34. All right, this you may need to memorize. The pH equals the negative of the log of H positive. All right. Now this goes back to what we've already learned, being able to go between exponents and logs to exponents. But I don't like this negative out front. So I'm going to move the negative here and make that positive. So that's negative 5.34 equals the log of H positives. Now I can rewrite this in exponential form. What's my base? 10 is the base. What's my exponent? Negative 5.34 equals my H positives. All right, that's how you're going to work those.
What does H positive mean?
That's the hydrogen ions. Okay? Got it? All right, they throw this problem in there and give no explanation for it, except to give you the equation. Okay, got it? Now,
What was it? Is this we're doing?
we're doing 118. That was a problem from 117.
Okay, yeah.
So you're going to see these
forward.
forward. That's right. You're going to see these forward. All right. There are laws to logarithms. The laws are the same rules we use for exponents. Okay, so like I really need you to lock in now. All right? Of course, I need you to lock in before, right? Just like we worked exponents when I had a common base, what could I do? Drop the base, set the exponents equal to one another. Okay? I can, the first rule of log says, if I have two equivalent logs with the same base, I can drop the log and set the arguments equal to each other. Like, they have a common base. The base is 10 when it's not written. These arguments have to be equal. So I can set 2x equal to 10. So a single log equals a single log. I can drop the log and set the arguments equal to each other. I'll show you another example. A single log equals a single log. I drop the log and set the arguments equal to each other. Got it?
Oh, yeah.
Got it?
Because they have equal bases.
What?
The same base.
What if the, I forget what it's called, the tiny number
Argument?
beside the argument beside the log isn't, if the argument beside the log isn't equal to the other argument, like how that says log 5 and the other one says log 5, do you just keep the log on both of them?
You're going to make it a common base. It's
Oh,
always
okay.
going to be a common base.
Okay.
Yes. Okay.
Just wanted to make sure.
Yes. Okay. Got that one? That's number one. And you remember, multiplication is what?
Addition.
Multiplication is addition. So I'm going to show you an example of this. Okay, I'm just going to use numbers. That's multiplication. Arguments multiplied means that we can add logs. So that equals the log of 6 plus the log of 4. So when your arguments are multiplied, you can add them as separate logs. So if you did the log of 24 in your calculator, everybody do it. Log of 24. You get 1.3802. Does that equal the log of 6? 0.7782 approximately, plus the log of 4.
Yes.
One has to be O and one. It does. It does. So if I have the log of 6x,
You know.
then that can be the same as the log of 6 plus the log of x. All right, so when arguments are multiplied, I can add individual logs. Got it? So multiplication of arguments is addition to logs. Multiplication of arguments is addition to logs. All right, so what do you think happens when arguments are divided?
Subtract.
Correct. Arguments divided, we can subtract the logs. All right, so if I have the log of 6 divided by 2, that's the same thing as the log of 6 minus the log of 2. Arguments divided means we can subtract the logs, and we can prove that. So we're using numbers first, and then we'll use letters. So the log of, and I am literally putting 6 divided by 2 in my calculator, that's 0.4771. Does that equal the log of 6, which is 0.7782, minus the log of 2, 0.3010. Well, we're off by 1 decimal place. But if I would have carried it out as far as the decimal places that were in my calculator, it would have been the exact same. All right, how are we going to use this? We're going to use this when we have variables. So if I have the log of x divided by y, that's going to be the log of x minus the log of y. So when arguments are divided, we can subtract individual logs. All right, so now, what do you suppose will happen if I have an argument raised to an exponent? We're going to multiply. All right, so the log of 3 squared
Equals the log.
2 times, we're going to multiply 2 times the log of 3. So if you do the log of 3 squared in your calculator, well, you get 0.9542. And if you do 2 times the log of 3, you get 0.9542. How are we going to use that? The log of x squared equals what? 2 times the log of x. Make sense?
Wait, but so just are you using it to solve that?
We are going to solve for x. Yes, we are.
So there are a few of these that are
We're expanding.
fractions. Yeah. Okay.
Okay, we're gonna do something. So look at number 1 on your handout. What does the log of 6 times 11 equal?
The log of 6 plus the log of 11?
Yes.
But is that the answer?
Yes, you're just expanding it. So you're getting accustomed to using the laws of logs.
Oh.
What is the log of 5 times 3?
Log of 5 plus log of 3.
Okay, now look at number 3. We have 2 different
Log.
rules. The first thing you're going to do is pull the exponent out. 5 times the log of 6 over 11. And division is,
Subtraction.
so that's 5 times, and you could open a parentheses. You could write this either way. The log of 6 minus the log of 11. Or you could have written this as 5 log of 6 minus 5 log of 11. Because it's 5 times that
you
whole
just
term.
distribute-
You just distributed it, yes. All right, 4 is different.
What?
4 now says the log of 3 times 2 cubed. The whole term is not cubed.
Just
Only
2.
the 2. So multiplication is,
Addition.
so what does this look like?
It would be log 3 plus
3
2.
log 2.
Plus 3 times log 2. You could have originally have written this as log 2 cubed, but then you pull that cube out front. Okay, so what is 5, Mary Frances?
4 log 2 minus log 5.
Correct. 4 times log 2 minus the log of 5. Got it? Hannah, what's number 6?
6 log of 6 minus 6 log of 5.
Yes. Got it? Emma, what's 7?
Log x minus 6 log 5.
Yes. Micah, what's 8?
8 is log A plus 2 log B.
2 goes with both of them. So it'd be 2.
Oh yeah. 2 log A
Plus.
plus 2 log B.
Yes. All right. What would 9 be, Beckett?
Log U4 minus. Oh wait. Oh yeah.
Yeah,
4
log u to the
Okay.
4th minus,
minus log V.
and then what would you do with that 4?
You also bring.
Pull it
the
out to the
side.
front. That's right. So it'd be 4 log u minus log v.
Mhm.
Leah, what would 10 be?
Log x minus 5 log y.
Yes.
Okay, I think we can do 11.
Okay. Okay. Tell me, Leah, how are we going to do 11?
Well, would you just like change the exponents to 1/3?
Yes. I change it this way.
Do you have to write it like I wrote it with all of them?
It is with all of them.
So do you have to?
1/3 log x plus 1/3 log y plus 1/3 log z. Yes, because it's on the outside.
Does that extend
Huh? That's expanded, yes. Well, no, this is not expanded. What I just said was expanded. 1/3 log x plus 1/3 log y plus 1/3 log z. Got it, Lydia? What's number 12?
Log x plus log y plus 2 log z.
Correct. All right, look at the logarithmic equations. Yes! Okay, I'm so glad. All right, look at number 1. What would I do with number 1?
Oh, it would be log 3 over log 3 over.
Okay, I have a log equals a log with the same base. I can drop the log. Logarithmic equations is probably page 4, maybe.
No.
I just stapled them all together to give y'all all you and I gave you the answers. Got it? Do you see number 1?
The log 5x. The log 9.
Yeah, log 5x equals a log 2x plus 9. I can drop the logs. I can set the arguments equal to one another. Got it?
Oh, so 5x equals 2x plus 9.
All right, so a log equaling a log is not hard. But then there are 2 other options of equations. Okay, guys, I need y'all to get this. All right? There are 2 types of log equations. The first type is every term is a log. When every term is a log, we're going to set a single log equaling a single log, and then we're going to drop the log, and set the arguments equal to one another. That is like your example 1 on the bottom of page 480. I'll write it. All right, now we're going the other way. We have logs added, so what can I do to their arguments? Multiply them, because multiplication is addition. So I can multiply them. We're going backwards. Got it? All right, so I could write this as a single log base 3, 2 times x plus 7 equals log base 3 of 20. Now I have a single log equals a single log. I drop the log. I set the arguments equal to one another. So 2 times x plus 7 equals 20. Got it? I can solve. Divide by 2, both sides. I have x plus 7 is 10. Subtract 7, x is 3. So then going back here, I have the log base 3 of 10 plus the log base 3 of 2 equals the log base 3 of 20. Does that make sense? Yes, because logs added means we can multiply the arguments. Make sense?
Yes. Yes.
Okay, now, either all logs, single log equals a single log, okay? If we have a constant, we have an equation where we have a constant. Which they don't give you one of those examples, but I'm going to give you one. So I'm going to use this one, and I'm going to add a constant to it. So log base 3 x plus 7 plus log base 3 of 2. And I'm going to say it equals 5. We have a constant. Make sense? If you have a constant, this is what you want to do. You want to make a single log equals the constant on the other side. Then you want to write that log in exponential form. So then you're going to write log in exponential form. So we want a single log
So
on the left. So it's going to be, what's this is a single log?
log base 3. I can't see. Is it x plus
2
7
times-
times x?
Yeah.
I mean times 2.
2 times x plus 7 equals 5.
How do you guys solve that?
So I can rewrite this as 3 to the 5th equals 2 times x plus 7. All right, so all logs, we want a log equals a log. And then we're going to drop the logs and set the arguments equal to one another. If I have a constant, then I want a single log equals the constant, and I'm going to rewrite it in exponential form. All right, we did example 1. Let's go do example 2. All right, example 2 is solve. Log base 14 x plus 3 minus log base 14 x minus 3 equals log base 14 7. All my terms are logs, so what do I want? I want a single log equals a single log. When logs are subtracted, what do we do? Divide the arguments. So on the left-hand side, it's log base 14 of
X plus 3 divided by x minus 3
equals
log 14.
of 7. I drop the logs. I set the arguments equal to one another. How do I solve this?
Multiply x minus 3.
Correct. Multiply both sides by the denominator to eliminate the denominator on the left-hand side. I'm left with x plus 3 equals 7x minus 21. I'm going to move my 21 to the left and my x to the right. So I have 24 equals 6x. What does x equal? 4, not 6, Paula. 4. All right, then I'm going to go back and say, does that make sense? The log base 14 of 7 minus the log base 14 of 1, does that equal that?
Yes.
Yes, because 7 divided by 1 is 7.
This is fun.
Okay?
Okay. Until I forget it all.
Until I go home and I try to do my homework.
All right,
And I
look
forgot.
at the last example. 3 log, they have b as the base. I'm just going to leave the base as 10. Equals the log 64. What am I going to do with this 3?
Wait,
Put it back as an exponent.
Put it back as an exponent.
oh.
Log of x cubed equals the log 64.
Okay.
Drop.
Oh, because that's what we were just doing.
What is x?
Cube root of 64 is like 3, 4.
4. Got it? Does that make sense? Does 3 times the log of 4 equal the log of 64? Yes. Because 64 could be written as 4 cubed. All right, let's look at the equations handout that I gave you. We just have like a minute. Look at number 6, logarithmic equations. Look at number 6. Okay, let me say one thing. Your argument, the value of your argument, are you listening? The value of your argument will never be a negative number. Never. Why can the argument not ever be a negative number?
I'm not sure.
Okay, because
it's an.
can I ever raise 10 to a power and get a negative number?
Oh no. And the base is 10.
So your argument will never ever be a negative number, okay? All right, now look at example 6. Now what I multiply can be a negative number. All right, what would I do here?
Move the 2r to the other side.
Move the 2 here. So log base 7 negative 2r squared equals 0.
7 to the 0 equals.
Correct. 7 to the 0 equals negative 2r squared, and that's 1.
1. So R is 1? Wait,
I squared negative 2, I squared r.
oh.
I'm going to now divide by 4.
Square root. 1/2 equals r.
That is correct.
This is fun.
All right. Look at number 9. Actually, look at number 10. Okay, we got to finish, y'all. Number 10. Negative 6 log base 3 x minus 3 equals negative 24. What do I do with this negative 6?
Put it on as an exponent.
Negative 6 goes there. Then I go to, because I have a constant, I'm
3
going
to the
to,
negative 24.
yes, 3 to the negative 24 equals x minus 3 to the negative 6.
And then we can solve that.
We can solve that. We could actually take, put it in the denominator, 1 over 3 to the 24th, 1 over x minus 3 to the 6th. We could take the 6th root, that's 1 over 3 to the 4th, because it's 24 divided by 6, equals 1 over x minus 3. And then you can solve from here.